piecewise functions. Here's what a piecewise function will look like. F of x, which is just the name of this particular function, is equal to 2x plus 3 when x is less than 2 and negative 3x plus 1 when x is greater than or equal to 2. So this function right here, or this expression right here, 2x plus 3, can only be evaluated for values less than 2. And that's what this piece right here says. Negative 3x plus 1, that expression can only be evaluated for x's 2 or greater. So for example, we'll have f of negative 2. Now f of negative 2 means the same thing as x equals negative 2. But we're going to write this as f of negative 2. So f of negative 2 is in this interval x less than 2. See, negative 2 is less than 2. Therefore, we're going to use this expression 2x plus 3. So it's going to look like this. F of negative 2 evaluated for 2x plus 3. You're going to substitute the negative 2 in for the x. So negative 4 plus 3, which is negative 1. So f evaluated at negative 2 is equal to negative 1. F of 0, 0 is less than 2, so f of 0, we're going to use the 2x plus 3 expression again. Substitute the 0, 0 plus 3, so f of 0 is equal to 3. Another example. F of 2. Now, 2 is equal to 2. See this, x is greater than or equal to 2. 2 is equal to 2, so we're going to use the expression minus 3x plus 1, because we're being defined in the interval of 2 or greater. So you substitute the 2 in for the x, so you get negative 6 plus 1, which is negative 5. So f of 2, this function up here, this piecewise function evaluated at 2, gives you negative 5. Here's another example. F of x equals x plus 2 defined on the interval of x less than negative 3, which means that we can only evaluate x plus 2 for numbers less than negative 3. And we have x plus 2x plus 1, and this interval is from negative 3 to 4. And this is going to have 3 expressions. Negative x plus 3 for x greater than 4. So now we have 3 separate linear expressions here. And we're going to evaluate f of negative 3. So we're going to use the x plus, the 2x plus 1. And I said negative 3. I first started looking at this one here because it had a negative 3 in it. But I can't use that one because it says x is less than negative 3. I have to use this middle expression because negative 3 is less than or equal to. So the negative 3 belongs to the 2x plus 1. So I substitute negative 3 in for the x. So I get negative 6 plus 1. So the function evaluated at negative 3 is equal to negative 5. Let's do another piece of this. Let's evaluate f of 0. So I'm still going to use this 2x plus 1. So f of 0 is equal to 1. One more example. F of 6. Now we're going to use the negative x plus 3 expression because up here x is greater than 4. So I'm going to use the x plus 3 function because I'm evaluating at 6. 6 is greater than 4. So I substitute 6 in for the x. Notice that minus sign stays there. So that's negative 6 plus 3. So f of 6 is equal to negative 3. Now notice that we never used this x plus 2. This x plus 2 expression right here, we never used that. That's because we were not given a value less than negative 3. If we would have been given an x of negative 4 or negative 6 or negative 22, then we would have evaluated this x plus 2. But because we weren't given that, we did not evaluate that piece right there. And that's perfectly acceptable. Okay, so there you have it. Two examples of evaluating piecewise functions. The next examples that you'll see in the next video will be on graphing piecewise functions.